All right, fifth graders, good morning and welcome back to another day of algebra. Today I want to work on a few expression items with you, and then we're going to do a little bit of expression writing and solving by the end of today's lesson. So for today, what I wanted to do was give us a little bit more guidance in solving certain expressions, and then you're going to see me write them on the board here on the side of your screen. And then what I'm also going to do is show you how to type these into the computer, because algebra on the computer is extremely hard to program and understand. And if you enter something that's slightly different, it might look one way in handwriting, but to a computer trying to solve it, or a computer trying to think about what the order of operations would be, it would be a little bit different. So let's take a look at this morning. And just like we're going to start out on page 179 in our packets today, I have some sample problems that will help us with understanding how to do those problems on pages 179 and 180. So the first thing we're going to do right now is write an expression for this Max problem. And Max has B baseball cards. He keeps 8 for himself and then divides the rest equally among 5 friends. So we're writing an expression, okay? So can we solve? No, we can't solve. What pieces of information do we know? So he has B baseball cards, he's keeping 8 for himself, and then he has 5 friends. And there's a key word here, and that key word is divides, right? So I'm going to be thinking about using a division expression. And we know that division expressions, when it comes down to algebra, we write them in fraction form, as Mrs. Duffy introduced to us the other day. So I'm going to have this expression be divided by 5. Now, I'm not done yet, because obviously I don't have an operator in my numerator. So the problem says Max has B baseball cards, and he keeps 8 for himself. Well, what he's going to do is have his collection, as I'm thinking about this. He's going to have his collection, he's going to take away 8 cards from that collection, and then he's going to divide the rest equally to 5 of his friends. So he's going to take his entire collection, which is B baseball cards, and take 8 away. So what operation is going to allow Max to take away 8 cards? And absolutely, that operation is going to be subtraction. So if Max does B minus 8 and then divides that by 5, we're going to find out exactly how many cards he gave away. Now, I wrote this as B minus 8 divided by 5, right? And if I make this look even prettier, the 5 is nice and centered. Now, when you go to enter this on the computer, in a Google form, for example, or on anything else, the computer is not that smart. And if I were to enter this on the computer, you know that you learn to add, or put in rather, B minus 8 divided by 5, right? Well, your computer is a great mathematician. It follows the order of operations. So if you were to tell your computer to do B minus 8 divided by 5, your computer is not going to do B minus 8 and figure out Max's collection first, or what he's going to divide up to his friends. The computer is going to say, oh, Max has a baseball card collection, but first I'm going to do 8 divided by 5 because I see division, and that's the order of operations. So in order to trick your computer, you have to add parentheses around that B minus 8, and that tells you to figure out first what Max has in his collection. Okay, so we can get in the habit of doing the same thing in our expressions and adding in those parentheses so that we can figure out how much Max has left over. Or I'm sorry, how much Max is giving away. In this next problem down here, we have me going to the store. Oh, how wonderful. I'm going to the store and I have $75 in my pocket. I buy 4 DVDs that cost some amount of money. How much money am I left with? Well, I have to ask myself a few questions. How much money did I start with? And the answer to that is $75. And then what did I spend? Well, I bought 4 DVDs, and they're going to cost C dollars, and we're going to add another word here to make this more clear. They cost C dollars each. So if I spend 4 DVDs C dollars, I had to multiply those two things together, right? So what I've spent is 4 times my C dollars. Can I write that as 4C? Absolutely, it's multiplication, and with multiplication in algebra, we don't write a multiplication symbol. But the question doesn't ask me, how much money did I spend? The question is asking me, how much money am I left with? Well, I spent 4C dollars. So I'm going to have to, in this empty space over here, figure out how much I am left with. So I started with $75, right? And now I'm going to have to spend 4C dollars. So what am I going to do? Am I going to add, subtract, multiply, or divide? So in order to figure out how much is left over, I'm going to have to subtract the money that I spent. Okay? So I spent 4C dollars. Therefore, I have 75 minus 4C dollars left over. And order of operations works out fine for me in this case, because if I spent $8 on a DVD, then I can plug and play and say 32. If I spent $12 on each DVD, I can still plug and play and work with those numbers. So whatever the cost is, multiply it by 4, because that's how much each DVD is. That'll give me my total cost of all my DVDs, and then I subtract it from the amount of money that I started with. All right, so we're off to a really good start so far in writing expressions. Remember, though, to use your grouping symbols when appropriate. All right, so we have a few more that we can take a look at today, and we're going to add 3 to the product of 6 and F. These are nice to write out on paper first, and you're just going to see me typing in answers underneath as we go along. Let's see, can I type in here? Yes, I can. Okay, so add 3 to the product of 6 and F. Okay, so I'm going to add 3. So I'm going to add 3. However, there's something that comes first. I have to take the product of 6 and F. So when I think about the product of 6 and F, product tells me that I'm going to do multiplication. So I can write the 6 and the F right next to one another. Now this expression, 6F plus 3, I have the product of 6 and F, and I'm adding 3 to that product. Therefore, I'm in good shape, and I'm done. This next one is going to look a little bit strange on the computer, and that's because we're dealing with quotient and division expressions. All right, so in this next problem, we're going to be subtracting 6 from the quotient of 8 and y. We don't know what y is. We don't know if this is going to be a decimal or a fraction answer yet, but we have to figure out what we're going to be doing here. So I'm subtracting 6. So I'm going to jot down a minus 6 right now. I'm going to move it over. So I'm going to jot down a minus 6 because I know I need to subtract. But I'm subtracting 6 from the quotient. So that 6 is going to come after my quotient. And I don't have access to a wonderful division symbol, so I'm going to be using the slash symbol again. And if I do 8 and y, the quotient of 8 and y, that means 8 divided by y in algebra terms. So I'm going to do 8 slash y minus 6. And if you wanted to be really safe with your computer, you could always add in grouping symbols. Even though your computer would ideally do 8 divided by y first, you can also remind yourself, hey, I need to divide 8 and y before I do whatever that is minus 6. I don't want to trick myself and not follow order of operations and do y minus 6 first. So using your grouping symbols, while it's not necessary, may help you out in figuring out what the proper expression would be. This next one says divide the product of 5 and t by 3. So this is a very, very peculiar phrasing, but it's one that is extremely important in algebra, and it's a type of expression that we're probably going to end up seeing a lot moving forward in our studies of algebra. So divide the product of 5 and t by 3. So we're going to divide by 3 according to the phrasing here. And then I'm being told that I have to use product of 5 and t. So that tells me to use which operation? It's telling me to use multiplication. So I can write 5 times t, which is just 5t, right? And then I can divide that by 3. Now, following order of operations, my computer would solve for 5 times t and then divide it by 3. Could I add in grouping symbols? Absolutely. Okay, if I wanted to add in groupers around this, I could definitely do it and work it like that. If I'm writing this out on paper, it's going to look like 5t, and then let's see if I can get this to space down. It doesn't space very nicely. But I can do 5t and underline that so I get a fraction bar. It's 5t over 3. So that's how this is going to end up looking when we go to format it as a fraction. It's really going to end up looking more so like our b minus 8 over 5 question that we did earlier. So this is how we're going to be constructing expressions based on things that are being told to us. The final thing we're going to take a look at today is evaluating expressions. And I'm going to bring the whiteboard back to the document camera. And I have some expressions over here on my whiteboard. All right, and continuing with the remainder of our lesson today, we're going to be thinking about solving our algebraic expressions. And when we're solving, we're kind of turning them into equations in a way where we're actually finding the value. Finding the value is perhaps the best way of phrasing this. Math and Focus, I'm looking over here, uses the term evaluate each expression. So we're going to find one number as an answer. We're not going to leave these as expressions any longer. And in each of my examples here, I've written in the middle of my page and I've written at the top of my page, we're going to solve when x is equal to 8. And we're going to remember that we should always follow the rule for order of operations as we solve. So I have 3x minus 7. And the first thing I have to think about is, well, 3x means I have to do an operation. Which operation is that? It's multiplication. So 3 times 8 minus 7. And now I have to follow order of operations. So following order of operations, I'm going to have 3 times 8 is 24. And then I'm going to subtract 7. And I will have 17 left over. And that's our first example. That's evaluating. We have evaluated the expression when x is equal to 8. Now, if x was equal to 9, could we have a different answer? You bet. We'd have 27 minus 7. Or I'm sorry, 27 minus 7, yes, is 20. Okay, so it would be a much different problem. We're only evaluating, though, when x is equal to 8, because that's our directions. Now, in this next problem, we have 2x over 4. And I have to think to myself, well, 2x means something. 2x means 2 times x. So I'm doing 2 times 8 over 4. And fifth graders, you might be thinking, well, I know order of operations tells me to do multiplication and division in order from left to right, but what about up and down? This is going to look a little bit peculiar to me. And you're absolutely right on that. So what we have to think about is remembering, one, we're going to solve in our numerators first. So there's kind of like an invisible grouping symbol up in our numerator. But we also think about how this is written if it was written flat on one line. So I have 2 times 8 divided by 4. So this would really say 2 times 8 divided by 4. Or on the computer, 2 times 8 divided by 4 using the slash symbol. So order of operations shows me that flat on one line from left to right, I'm going to do 2 times 8 first, and then I'm going to divide by 4. So 2 times 8 is going to equal 16, and then I'm going to have my 4 left in my denominator. So 16 over 4, 16 fourths is 4 whole. Okay, so we've made it through those 2 examples so far. We're doing really well. What we'll do next is think about still when x is equal to 8 in each of these. And remember I said in our previous example that we want to think about the grouping symbol, just kind of being there invisibly and guiding us to solve that numerator, simplify that numerator first, and then working across the division symbol. So I'm going to add in that grouper there just to remind me that even though there's division here, I want to do x plus 1. I want to solve what is 8 plus 1 first. So I'm going to write that down. 8 plus 1 divide by 3. And if I do, for example, 8 divide by 3 plus 1 divide by 3, all right, fine, I'll get my answer. It's going to be easier to evaluate that numerator though. So 8 plus 1 is 9 over 3. So 9 over 3 is 9 divided by 3, which is quite simply 3. All right, same thing is true in this final example. We're going to remember to do 4x minus 7 divided by 5, have our grouping symbol in there. And I'm going to end up doing 4 times 8, 4 times 8 minus 7, all over 5. And I just use the term all over 5 to tell me that I'm going to be dividing everything that's in my numerator by 5. So when I follow order of operations, remember, I'm still following my grouping symbol. So I'm simplifying that numerator first. 4 times 8 is 32 minus 7. And then I'll divide that by 5. And my grouping symbol still is not gone because I'm following order of operations inside that grouping symbol. So I did my multiplication first. Now I'm going to do my subtraction in the grouping symbol. So 32 minus 7 is 25. And I'm going to divide by 5. 25 over 5 is 5 whole. Today, ladies and gentlemen, you're going to be working in your workbook, or your worksheet packet rather, on pages 179 through 181. There are a couple tricky problems, especially on page 180, so think very carefully about what the problem is asking you to do today. I'm confident you'll be able to get through this challenge though. Go back and rewatch this video anytime you need a little bit of a refresher or anything clarified. And we'll talk to you later on. Reach out with any questions you might have. Thanks, guys.